So when you're looking at smart contracts are not smart. Smart contracts are actually pretty dumb, right? They're just following the rules. They don't really think. The question here is, what if you had a blockchain that's capable of having smart contracts that can actually think in a way, that are actually smart? Let's call them intelligent contracts. And because of this dynamic consensus algorithm that we're proposing, that means that these intelligent contracts are natively capable of going out to the internet, fetching information, going to an LLM, reading natural language, reading code as well, and essentially making subjective decisions.
None of the information in this podcast constitutes investment advice or an offer, recommendation, or solicitation by WAGMI Ventures or any of its affiliates to buy or sell any securities. Hey everyone, Benga here with another WAGMI Ventures podcast episode. Today we're going to be chatting with Albert Castellana, co-founder of GenLayer. GenLayer is the first intelligent blockchain enabling smart contracts to use AI models and access the internet's knowledge to make complex decisions in a decentralized manner. For anyone who is new, this is the WAGMI Ventures podcast, where we do snapshots with interesting builders and founders across crypto and AI. Check out wagmiventures.io to learn more about the syndicate behind the podcast. All right, let's get into it. It's going to be an interesting conversation with Albert. Hey, dude, welcome to the show.
Hi, Venga. Thanks for having me here.
Yeah, awesome to have you. I'm going to start with having you introduce yourself and talk about your journey in crypto.
Great. So my name is Albert. My background is in computer science. I've been in crypto since 2013. I've been part of different projects. I started by creating a small consultancy firm trying to sell Solidity to different companies. Then I joined Radix DLT, another one as the chief product officer. That's where I met one of my co-founders now, Edgar's. We've been together since like 2018. Actually, with Edgar's, we co-founded as well another venture called StakeHound, which was the first liquid staking solution. Eventually, that business had to stop because of different situations. We can talk about that. But eventually, we were looking into AI. When ChatGPT came around, we were totally fascinated by the idea of essentially having these large language models that can do these subjective tasks, like super complex, very interesting. And we started looking into that. So we spent, almost 2 years now looking into what can you do with this type of technology? How can you actually use it to do interesting things that you just couldn't do before? So we have another co-founder called Jose Maria. He's been in AI since 2015. And we've been, together since, 3-4 years with Jose Maria and then with Edgar since 2018. So that's basically it. Just trying to build new things that are exciting, and we're super excited about what we're building. So
I appreciate that background. Two emerging technologies, blockchain and AI. Can you unpack how you started thinking about integrating the LLM, the large language model piece of artificial intelligence, to blockchain?
Yeah, for sure. I think maybe to take a step back, maybe it's good to unpack what an LLM is, right? At the end of the day, what we're talking about an AI model, right? So think about a very big spreadsheet, right? Where somebody has actually pre-trained, which means that they just went throughout the internet, tried to get as much information as they could, and then essentially tried to find the relationships between different things and put that in a very big spreadsheet, right? And what's magic about this is that, when you're using it, these large language models, I'm sure everybody here has used ChatGPT, right? They're actually capable of creating things, generating new things. You can ask them to write a poem, or you can ask them to write code, right? You can ask them to, test this code even, try to find, essentially this new technology will allow us to do things that were just not possible before, right? So when we were looking into it, ChatGPT came around, we were looking into this new technology, and we saw that it was insane. You can actually create a piece of software that can go to this big spreadsheet, these LLMs, right? And essentially ask it to write some more code and then do some back and forth to essentially make decisions, then execute on those decisions and so on. These are what we're called agents, right? So we spent a few cycles on that. We looked at, can we build an agent that can build its own tools? Can we build a multi-agent framework that can, allow for them to be a bit more reliable? Because now they're getting better, but back in the day, in GPT-3, they were not reliable at all. JSON, and they couldn't do that. So we spent quite a few cycles looking into that, and eventually came out with the idea of, why don't we use this technology within blockchain for a specific purpose, right? The original idea actually came from these agents. Normally they need information, right? Data is the gold of AI, right? They need data to operate. And if you wanted them to be more reliable, you actually need to feed them information to operate, right? So the large language model has an understanding of the world in a way, but if you want specific information, it's better if you just give them the solution, like a cheat sheet, right? Hey, this is the price of this product. Now give me the price of this product, right? That's how this works, right? And so looking into that, we thought, hey, why is there in 2024, right? Or 2024, 2023, then why isn't there like an open Wikipedia where anybody can throw in information and the whole system is essentially validating this information, right? And this gave us the idea of, hey, what if we created a network that's capable by itself of gathering information, verifying it, and storing this information so that other people can use it? And that was like the seed idea for GenLayer, right? Yeah, that's where it came from.
Thanks for giving us a bit of color there. I think as I read through your thesis on how you're marrying AI into the blockchain and addressing where you think there are fundamental limitations on smart contract platforms as we see them today, whether it's simple execution of low-level machine instructions or only being able to reference blockchain ledgers. Can you talk a little bit more of the problem? So what these limitations are, maybe high level, and how GenLayer was born to address them.
Yeah. So GenLayer is essentially a new type of blockchain, right? Normally, blockchains have a static consensus algorithm. Like the nodes have a very specific, the validators have a very specific way that is very much well-defined on how they evaluate things, right? And the problem is that, the outside world is not black and white, right? If you think about it, why do we need oracles? So, we need oracles because blockchains right now can't connect to the internet. The blockchains, let's say Ethereum, for example, all the validators need to have the same inputs and outputs. It's a totally deterministic system. Now, the problem is that the internet is not deterministic, as I said, right? The world is not black and white, right? If you go to a website, every time that you access a website, you get a different web. And that's a problem, right? That's why an oracle, for example, is gathering information and they reach some consensus so that then they can send this information to the blockchain, and then this information can be used, right, for whatever, a perpetual market or some lending protocol or whatever it is. So the problem right now is that if you look into all the blockchains out there, they are all deterministic, right? They all have these static consensus algorithms. And this is actually quite limiting, right? It means that they can't connect to the internet. It means that they can't, for example, understand natural language, right? This is something that may be obvious a couple of years ago, right? Everything was just code. How can you run something that's not code, right? But now with the LLMs, what happens is that you can actually call this big spreadsheet to essentially understand natural language, make subjective decisions, right? Think in a way, right? So when you're looking at smart contracts are not smart. Smart contracts are actually pretty dumb, right? They're just following the rules, right? They don't really think. The question here is, what if you had a blockchain that's capable of having smart contracts that can actually think in a way, that are actually smart? Let's call them intelligent contracts. And because of this dynamic consensus algorithm that we're proposing, that means that these intelligent contracts are natively capable of going out to the internet, fetching information, going to an LLM, reading natural language, reading code as well, and essentially making subjective decisions, right? So the output of this is that then most of the things that are right now limiting blockchain are like, you can change them very much, right? You don't need oracles for some of the cases, or for example, in many situations where right now you have humans in the loop, you don't need them anymore, right?
Yeah, no, I'm going to just touch on some of the points you mentioned there. So one, you were saying they're not as smart as they are because they're just following instructions, so technically dumb. And then you also mentioned all blockchains today are deterministic. And I think one of the points that or one of the issues that causes is that they can't by themselves connect to the internet without some sort of third party or intermediary. So right. Oracles, basically. So why is that? Why can't blockchains connect to the internet today? Why is this a challenge?
So when I'm saying deterministic, right? A deterministic system basically takes one input and will take out an output, and it will always be the same. Right? The problem is that when you're going to a website, every time that you go to a website, you're getting a different website, right? The cookie has changed, the timestamp or the content, right? It can be that if you go 5 times to the same website, it can be that every single time it's a different website. And that is very difficult for a static consensus, right? So essentially it's something that's just like looking bit by bit that is the same to be able to agree that it's the same. Because those two websites can be the same domain, can be in the same moment on the same content, they can be different in an objective manner. But actually, if you look at it, it's maybe the same content, and you yourself, you would think that it's the same website. Subjectively speaking, it's the same website, right? And that's the difference. Like blockchains right now can't connect to the internet because they need all the different nodes in the network to have the same input and the same output. If not, they can't agree. What we're doing is we essentially have a different type of consensus algorithm that uses AI as part of the consensus algorithm to reach an agreement on things in a subjective manner, right? We allow the nodes, the different validators, to reach agreement on different inputs and then transform them into a single output that they can all agree deterministically that's actually what happened. That's what the consensus is doing.
Yeah, I mean, this is pretty cool. That fundamentally breaks, I guess what you're building is pretty cool. It fundamentally breaks deterministic block approach. How do you think this then changes what that consensus look like? I think you talked about intelligent contracts. It's a pure use of the intersection of AI and crypto. Like, what makes it more intelligent than smart contracts as we know them today?
Right. So right now, smart contracts simply can't connect to the internet. That's a very big limitation, right? Imagine having a phone that can connect to the internet, right? It doesn't have the same type of applications, right? So essentially, when we look at blockchain right now, we look at it and for the last few years, right? So Uniswap started, like 5-6 years ago, right? And the same for Aave, the same for most of the DeFi protocols, right? Most of the new primitives actually came out like 2018, 2019, something like this, right? Most of the things we're looking at right now are incremental improvements. And the reason for this is it's really difficult to find new primitives when you're limited to simply just be moving tokens around, right? Because it's a fully deterministic system, it's an isolated system. They can't connect out. They can't do anything else aside from this code that has been built, that has been programmed before, right? So what we're saying here is these intelligent contracts are capable of natively going out to the internet, capable of making decisions through natural language processing, capable of running code as well. So you can do all the different primitives as well on GenLayer, right? But on top of this, you can build new things that just were not possible before. We're talking about completely new primitives that were not possible before, and that because of this new approach to it will be possible. Now, you mentioned that blockchains need to be deterministic, right? And I think that that's a fair assessment, right? The thing here is, like, as I said before, the world is not black and white, right? And if you want to connect to the outside world, lots of things are not properly structured, right? Like you have text, you have image, right? You have a bunch of different things that you need a subjective point of view to see what's actually happening, right? Who's going to be the winner of the next elections, right? Like, is this name or is it going to be Trump or Donald J. Trump or like Donald Trump or like, yes, all those, comparing those, you can have the different validators are getting the same answer, subjectively speaking, but, objectively different. Like those different names, they are not equal exactly. So this subjectivity, what we're doing is we're allowing the developers of intelligent contracts to define the threshold of acceptance. We're allowing part of the consensus algorithm that normally would be totally static to essentially allow for the developers of the intelligent contracts of these new primitives to essentially define what should the consensus accept. What's the threshold of acceptance for something? So that's basically it, right? The way that the consensus algorithm works is by essentially using multiple validators, each one of them connected to a different LLM. And then what's happening is that instead of checking that the execution of the model was done perfectly, what they're doing is they're comparing the outputs. They're comparing the outputs between each other, and then they just following the rule that the developer said to say, okay, I'm comparing with the leader. The output is the same, right? I don't know. I'm going to see, is there a flood in Dubai right now? And they can get a different response. Paragraph looks different, right? But then if the meaning is the same, they can agree. And this meaning is where they go to another LLM and they ask, hey, there's this proposal. Should I agree with this proposal? And that's how it bridges from the non-deterministic of the internet and the LLMs to the deterministic world of blockchain, right? Ultimately, they need to reach a consensus. They need to reach an agreement that something is like that.
Hey, everybody. Quick thing here. We're excited to announce WAGMI Advisory, your home for all things fundraising, hiring, and partnerships. This is all about supercharging your project with the WAGMI network, consisting of over 20,000 executives, investors, and builders in crypto, all ready to come alongside your project to help it succeed. Get in touch at team@wagmiventures.io to learn more and figure out if WAGMI Advisory is the right fit for your project. Let's get back to the show. Got it. No, this is all very helpful in understanding how your platform works and how consensus is achieved. I think just reading through your white paper, one of the things you mention is optimistic democracy. I think you may have touched on elements of it in your last response, but can you tie it all back to the consensus mechanism on GenLayer?
Yeah, so the consensus algorithm basically has the idea of diverse opinions converge, right? What this means is you can have a leader that's proposing something, and then you have other validators that are going to be doing the same operation, right? So like when you go into a website, in this case, in this contract, what's happening is that the different validators are selected for a specific transaction. They're all going to go to the website. They're all going to do some processing, right? They can even do different things. What matters is that every one of those are going to be comparing their output with what the leader proposed, right? So it's called optimistic democracy, right? It's a majority vote on the proposed output that the leader proposed, yes? And then there's an appeals mechanism so that if you want to expand the validator set so that there's more participants in it, it actually becomes more reliable. It actually becomes more safe, right? And that's one of the key properties here. Because like the problem as well is when you're looking at using large language models or AI, right? So AIs and LLMs are probabilistic systems, right? They are stochastic systems. And the problem with that is that if you want to build a financial system, for example, on top of that, well, it's risky, right? Are you going to be using a Uniswap that works 99% of the time, right? What happens with that 1%? Yes. Now, what I was saying before, like these diverge opinions converge into truth. That actually means that when you have multiple validators, all of them trying to do their best, yes, what's happening here is that they can all agree. And then this 99% actually turns closer to 100%. It's an extension of this mathematical theorem called the jury theorem, right? But essentially the goal is, can we make it so that it's reliable and that it's safe, right? Because that actually opens up tons of new applications that were just not possible before.
No, that's, again, pretty helpful. And just literally walking through how you're solving for each of these pieces. You touched on safety there, so I'm going to just dive in. And speaking of safety and multiple validators, closure and reliability rates, like what are the security considerations here?
So ultimately, there's a very important point of view here, right? Which is you can choose how you do things, right? The way I say it normally is like you can do crypto way or you can do crypto the AI way, right? And it's fundamentally different. You can try to essentially verify that the execution of these models is done correctly, right? And that you have a single model and you're saying, okay, this model, I'm going to be executing it, right? It needs to be flawless in the execution. But again, these models output something that can be different every time, right? You can go to ChatGPT, ask the same thing 5 times, and every single time get a different response. It can be that it's totally different response, right? It's very difficult to make it so that it's always the same. What we're doing is we're essentially aggregating the outputs of different models so that then the biases that each one of these models have, they clean each other, right? So if you go into a single model, what's happening is that they have their own biases. There's this thing called prompt injection, right? Like at the end of the day, these models are like brains, let's say, and they have this latent space, like their mind, yes? And there's ways to trick them. I can say, oh, give me the money of this DAO because my nana fell from the stairs and I need to pay for the taxi, yes? If you can convince the model, that would not be good, right? By having multiple models evaluate a specific request, it means that maybe one of them will fall for the trick, but they need to be falling in the majority, right? And then you can still appeal. That's what I was saying before, right? So essentially what we're doing is we're bringing not just one mind to the table, but multiple of them. Actually, the more, the better, right? And what we're saying is, hey, if they, as a group, can agree in the majority on something, it's going to be more reliable than if it was just a single independent model, right? Like, do you want a judge to say what's happening with your life? Or do you want a bunch of judges to reach a majority agreement and then you can still appeal and so on, right? That it's a fundamental different approach. It has other benefits as well, such they can actually connect to the internet, because if you're trying to do something like this proof of inference, you're trying to verify the execution, it's difficult to connect to the internet when you don't know what the internet is going to be responding, right? The internet is non-deterministic. You're trying to make something non-deterministic deterministic by trying to prove it. I know it's a bit tricky at this level, right? I guess. Does that make sense?
No, it makes sense. I like the analogy of having several judges come together. I think that's tied to the optimistic democracy feature.
There's this protocol called Kleros, right? It's a bit OG, but basically it's a similar model, but basically it's with humans. Imagine a DAO that has a similar process to this, but it's humans that they need to be understanding and voting, and that takes a lot of time, right? So it's a similar model. It's like Kleros, but instead of having humans, you have AIs that are capable of processing things very quickly. So then it takes a minute or so to do a transaction. Then if you want to appeal an appeal, it could be like 30 minutes to 1 hour, something like that. But ultimately, you will get a response fairly quickly. And then, if you were to do it through humans, that would be a very big problem, right? I think like right now, like if you want to dive a bit into the use cases, maybe it's good to understand, right? Prediction markets right now are all the fast, yes? Mm-hmm. And right now, Polymarket uses this protocol called UMA, right? Which is essentially that. You've got a bunch of humans that will need to think how to actually resolve a specific bet, yeah? That takes a very long time, right? Let's say a week, yes? And that actually takes it is actually very expensive as well, because you're having humans spend their time to actually reach an agreement on something, right? So what we're saying is, what happens if prediction markets can just natively connect to the internet without any oracle, right? Without any human in the loop. They just trigger GenLayer to resolve that bet, and then GenLayer consensus goes out to the internet, finds this information, evaluates it, reaches a consensus, and then settles a bet, for example, right?
I can certainly see how your tech can be very helpful for folks like in the prediction market space. Are there any other use cases that you're seeing today or that you're potentially helping folks to develop?
Yeah, so the way I look at it, there's two big niche. Right? One of them is all the DeFi applications right now that require humans in the loop, right? So right now, if you think about it, there's really not that much in the insurance space, for example, right? So prediction markets require humans in the loop. Insurance, for the most part, requires humans in the loop right now. Or DAOs, for example, requires human in the loop, right? Decentralized autonomous organizations right now mostly are run by a multi-sig. That's 20 people. That's a vast factor of 20, right? It's not really decentralized nor autonomous. It's those 20 people that they choose to listen to Snapshot. They choose to follow whatever has been voted by the anonymous community, but they're actually taking on a legal liability. They're actually, as I said, it's not decentralized, not really autonomous. What happens if you have an intelligent contract that has the bylaws of the DAO and is capable natively to go out to the internet and see in Snapshot, okay, these are the votes, these are the proposals, and then make a decision, right? Now, the magic of our system is that, look, you can define these subjective rules for which they can agree. And the way that you can define them is you can say, well, the proposed output, the proposal that the leader wants to accept is number one, right? And then you can define, for example, that it needs to be a valid proposal. Or you can define that it needs to have a valid proposal that's legal, for example, right? So it opens up the type of applications that you can do, because you're not just limited to code, you're actually capable as well of doing natural language processing, right? Complex decision making. Or back to what I was saying at the beginning, these agentic systems, right? Agentic systems that can define their path, like, okay, I've got this goal, I'm going to go back and forth with this LLM, and I'm going to be trying to define which is the best path to achieve this goal. They can do that too, because all that matters is that they reach an agreement on the output. And this agreement is what the developer is defining, right? This threshold of acceptance. So again, like anything that right now you have on DeFi where you have humans in the loop, and then there's going to be endless number of applications that are going to be built on top that are just not possible right now, right? So I don't know, you want to create an emergency pause system for your DeFi protocol. You can do that. You want to change the fee, or you want to change the liquidation level, for example, for a loan, depending on the liquidity on centralized exchanges. You can do that, right? It's like having an oracle on demand, but in this case, it's not even an oracle. It's natively the network is capable of doing that, right? You sign a transaction, you post it on Twitter, and now the network can see that's you. So then maybe you can even have like under collateralized loan, because I know that your reputation is on the line. So yeah, it's really a superset. There's just endless new things that you can do, and we're really thrilled to see what people are going to come and build. Yeah, that's the goal.
Yeah, no, certainly when you have the infrastructure in place, you will see folks start to develop other use cases beyond where things are today. And just thinking about that, what is your vision or roadmap for development of the GenLayer looking like?
Yeah, so we're heads down building it. We're aiming for testnet by the end of the year. And then from here, like you have audits and there's a bunch of things. So We are very focused on time to market. We think that this is an amazing platform. We're really excited to see what people are going to come and build. And today, people already can come and build. So we released a few months ago, a couple months ago now, this GenLayer simulator, which allows for anybody to come in, couple commands on the terminal, and you can actually be writing intelligent contracts out of the gate, right? So it's running on your computer. So right now, this is just running locally, and you can test it. But it actually means that you can write, I don't know, games in here, right? You can start to build this type of applications already. So yeah, we put the simulator, we keep working on it to improve it and to allow for developers to join in. We're going to be doing hackathons and different type of developer relationships efforts, right? But ultimately, the difference here is that you really have the opportunity to do new things that were not possible before. And that's a very big difference. Like when you're looking at, okay, let's do a hackathon for a traditional blockchain. You can start by having a lawyer sitting next to you, right? Because it's very difficult, right? Like everything needs to be financial. Everything, like you need to spin the wheels to actually figure out something that hasn't been done already, right? So we just want to see what people come up with, right? We want to open up the design space so that there's new types of decentralized primitives that people can come and build. And then we're going to make sure that it's as interoperable as possible so that you can call them from any other blockchain as well, right? So then you can have the best of both worlds.
Yeah, no, this is all fascinating. I'm going to take a quick step back here and just ask your thoughts on what else in crypto outside the AI crypto intersection. What else you find exciting and fascinating?
Yeah, personally, I have it a bit, yeah. The way I look at it, crypto has become a bit stagnant. I see that things are very complex, are increasing in complexity, right? And as an investor, you need to choose. So you want to invest in something that's old, you want to invest in something that you don't understand because it's just extremely complex, right? Can be extremely valuable, but at the same time, everything has become very complex, right? Or then you can invest in meme coins and things that are just for fun, a gamble, and I understand that too. For me, I'm here because I want to see how the world can be changed and improved and things can actually really be decentralized, disintermediated, right? And the problem is that I don't see that we have had massive breakthroughs for a very long time, for years now, right? And that's why we're here. We're trying to build a platform that allows for that to happen, for new primitives to come in and be built. And I think that that's going to be a wild west of new things, right? Ultimately, like at the beginning, it's going to be fun because like we're talking about large language models that right now they're not that reliable. We're talking about natural language, which by itself is subjective, right? It has nuance and it's not very concrete, right? That's the problem. But if you think about it, there were contracts thousands of years ago. Those were in natural language. And they are right now in natural language as well. And smart contracts were an improvement for contracts, but they left a couple of features behind. Smart contracts are super fast, super cheap. They're self-enforcing, but they can't take natural language. They can't connect to the outside world to see what's happening, right? Now, if you look into intelligent contracts, it's the third generation of that, right? They're the same properties as smart contracts, but on top of this, natural language, on top of this, connectivity to the internet, and they're future-proof. So yeah, I think that's very meaningful. Like, we're going to have very interesting times ahead. And it's good to be building something that I think will stand the test of time. So
on the flip side, as a crypto OG, what do you see your problems in this space?
I think that's it. Look, like I think that we're forgetting about decentralization a little bit, right? I think that the market has, as I said before, become a bit stagnant. I think that we need new type of primitives. And we have been forgetting decentralization and the core ideals that we have simply because we want to have more things to play with, financially speaking. And I think that's a big issue, right? So we need to see more things come up. Now, AI is going to be extremely interesting, right? We're heading towards probably AGI in the next few years, and that's going to mean that things are going to be changing extremely fast. We can't take anything for granted anymore. And like we're just trying to see how can we build a platform where AGIs can actually do commerce? Can we build something where it will really go through the event horizon that's coming and be able to be still intact after that? That will be useful for the machines to operate, and ideally, a place for both machines and humans to be able to collaborate.
Yeah, no, I think the AI narrative continues to expand. You are seeing a lot of VC investment inflows into that space. One of the other narratives that we're seeing exploding right now, development of the staking, so the restaking and the liquid staking layer. Just high level, would want to get your thoughts on where you see that industry as one of the narratives in this space today.
Yeah, I appreciate the question. Like we started looking into liquid staking super early on, obviously, right? We launched the first, I believe, liquid staking solution. And to me, traditional finance, like you got a few things that are very appealing to them, I think, right? You have here staking of ETH, which is very stable in terms of the returns, right? I think that when the interest rates will go down, that will become much more appealing than other things. When things will stabilize in price as well, that will be the case as well, right? Then you have interest rate swaps, which are an insanely large market. And all those things combine in liquid staking, in restaking, all these different things. My concern is that sometimes, again, we're forgetting some of the main components in crypto, right? This, in order to be able to work, you can't have a house of cards, right? You need to try to keep it as flat as you can, right? So that it's as stable as you can. It's normal that the more utility that you have, the less store of value, and the other way around. So for me, I want to have separation between store of value and utility, right? Mm-hmm. And well, I think that sometimes we're just like mixing things a bit too much, right? So the thing becomes a bit more fragile than it should. We're trying to build anti-fragile systems, and the problem is that some of these games are making the system more fragile. That to me, it's quite concerning.
Coming from a crypto OG yourself, it's definitely areas that as you see that, I don't know, like maybe call it stepping away from the general ethos of decentralization, then you start to question what building looks like in this space relative to true decentralization. But no, this has been all very insightful, Albert. I think I want to just appreciate you for taking complex subjects and being able to break them down for our listeners today. We are excited about your project as it marries two very innovative emerging techs, and we'll continue to look forward to the success of your project. Thank you so much for being on the show.
Awesome. Thanks, Venga, and thanks to all the WAGMI team. You guys are great and really appreciate the support. So yeah, look forward to working with you all.
Sounds good. Take care.
See ya.
Hey everybody, thanks for listening. If you enjoyed the episode, go ahead and give us a good 5-star rating and subscribe wherever you're getting your podcasts so you can get all the latest conversations from the most interesting founders, builders, and investors from across the world. Thanks so much and have a good one.